We're going to derive the famous quadratic formula. So suppose you have a quadratic equation, ax squared plus bx plus c equals 0. And you don't want a to be 0 because a times x squared will be 0. And then you would just have bx plus c equals 0. That's the equation of a line. Now, actually, it isn't. Bring this over, and you get bx is negative c, so x is negative c over b. Okay, that's the solution to it if x is, if a is 0. So we want a real quadratic, not a fake one. We don't want a to be 0. Okay, so the first thing we're going to do is factor out an a. So you have a times x squared. Now, you may say, wait a minute. B doesn't have an a. Fine. So multiply it by a, divide it by a. And that's b times a. Well, I factored out the a, so I'm left with b over ax. And this is the same as c times a over a. And I factored out that a. So I get c over a equals 0. Now, since a is not 0, if this times this is 0, either this is 0 or that's 0. But that's not 0. So this is 0. Now, we want equals 0. What we want to do is called complete the square. That is, actually, let's bring this over right away. So you have x plus b over ax is equal to negative c over a. Now, I want to add something special. Oops, that always was x squared, sorry. I want to add something special here to make it a complete square. And of course, I have to add the same thing to the other side. And if you look at a perfect square, if you have x plus b squared, well, you get x squared plus 2dx plus b squared. And we have like the x squared, or 2d is like b over a. Now, the question is, what could you do to 2d? Here is 2d. What can you do to it to get d squared? And one thing is you can divide it by 2, which gives you d, and then square it. So I'm going to take the b over a, and I'm going to divide it by 2. And it's easier than multiply by half. Divide it by 2, and I square it. B times 1 is b, a times 2 is 2a. Like I said, I square it. So I get the b squared, I get the 2 squared, a squared. So that's what I'm going to add in this bracket. I am going to add b squared over 4a squared. B squared over 4a squared. Let's get rid of our side work. Learn how to complete your squares. Okay, now what's on the left side is a perfect square. It's x plus half of that number. B over 2a squared. And it is equal to, I'll multiply on top and bottom by 4a. That way, the bottom is 4a squared. the same as that bottom. So I have 4a squared in the bottom. I have b squared minus 4 times a times c. 4ac. And if this squared equals this, then this must be plus or minus the square root of the other side. Now, plus equals plus minus. I do not know the square root of the top, but I do know the square root of 4a squared. The square root of 4 is 2, and the square root of a squared is 8. Okay. So I'm going to finish up by bringing the b over 2a to the other side as negative b over 2a. Plus minus what was always on the other side. This was 4ac. I don't know why I didn't put the c down. All over 2a. And we are done because in addition or subtraction, if you have the same denominator, keep it. And the top is going to be negative b plus or minus the square root of b squared minus 4ac. And this here is actually, so that's the quadratic formula. And what's in the box is two numbers. It's x is equal to negative b plus the square root of b squared minus 4ac over 2a and negative b, and now I use the minus the square root of b squared minus 4ac all over twice a. Now that was extra. Here is the derivation of the quadratic formula. Stop memorizing.